2016. GATE is a competitive examination taken by a million students every year. It is for higher education and job opportunities in the government of India. This is a question, a real life question from the theory of computation. Question 45 in the Computer Science and Information Technology paper. Paper 2. It's a multiple choice question. There are 4 choices and we are told one answer is correct, 3 are wrong. The area the question deals with is context-free grammars, which is part of theory of computation. Now, there are 4 choices. 3 are wrong, 1 is correct. If we can guess all the wrong answers, then what is left will be the correct answer. Once we have guessed all the wrong answers, we really do not have to verify that the 4th choice is the correct answer. The examiner guarantees it. Here is the problem. It says which one of the following grammars is free from left recursion. One important thing about GATE questions, every word should be carefully read. Here we can say we talked about one of the choices. We are told they are grammars. As per the syllabus, there must be the Chomsky hierarchy. We are told that of the 4, one alone is free from left recursion. There are 4 choices. Choice A, choice B, choice C, choice D. These are grammars. In these grammars, capital letters are non-terminal symbols and small letters are terminal symbols by convention. Epsilon is a special case of the empty string. We can see epsilon is occurring here, 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 and here. If I examine choice A, I find that the left-hand side of the rules contains a capital letter. That is a non-terminal symbol. That is sufficient for us to conclude that choice A is a context-free grammar. Let us come to choice B. The left-hand side of this rule is capital letter S, capital letter A for the next rule, capital letter B for the third rule. For the left-hand side of the rules are all capital letters, non-terminal symbols. So B is a context-free grammar. Let us consider C. C is also a context-free grammar. Why? The left-hand side of each rule is a non-terminal symbol. Capital S, capital A, capital B. So C is a context-free grammar. Let us consider choice D. The left-hand side of the rules again is a non-terminal symbol, a capital letter. S, A, and B. So D is also a context-free grammar. In this context-free grammar, we are told 3 of them are left recursive and 1 of them is free from left recursion. What is left recursion? It means the left-hand side non-terminal is the same as the first symbol on the right-hand side. So if some right-hand side has the same symbol, then on the left-hand side, it is left recursive. It can be slightly more complicated as we can see. Let us go case by case. Let us arbitrarily consider case A. Here is the context-free grammar containing 4 rules. This vertical bar means the right-hand side has 2 alternatives. Left-hand side is the same. Now, if I consider rule number 2, I find A is going to A. The second production is A goes to A, which means A is on the left-hand side. A is the first symbol on the right-hand side. So A is a left recursive non-terminal. So choice A cannot be the answer. Now A goes to A is a useful rule because from starting symbol I can come to A. From A I can come to A. So this is not a useless rule. So in other words, we can conclude case A cannot be the answer. Let us come to consider case C. Here is case C. Again, this is a context-free grammar. Now, S occurs on the left-hand side, S occurs on the right-hand side. and the first symbol on the right hand side of the right part. Let us see from S I can come to S. From this S I can come to A. From this A I can come to S. S I can come to A. From A I can come to S. A. So S occurs here, S occurs here. S is on the left hand side, is the first symbol on the right hand side. So S is a left recursive non-terminal. So case C can be eliminated as being a candidate for the answer. Let us come to case D. D is a context-free grammar. Here, for example, I have to test either the non-terminal S or the non-terminal A or non-terminal B. I find, for example, S occurs on the left-hand side here. S does not occur on the right-hand side anywhere. So we will not consider S. Let us consider non-terminal A. From S I can go to A I can go to B I can come to A. That means from A I can come to B I can come to A, and from S I can come to this A. So A is a left recursive non-terminal. So D cannot be the answer. So case D is ruled out. Now we are left with only one choice. Choices A, B, and D have been eliminated. So in other words, 3 of the 4 choices have been eliminated. The last choice is C. So C must be the answer. The examiner must ensure that it's totally correct once you have guessed all the wrong answers. So the answer is C. That is the end of the presentation. Thank you for your attention.